Okay, section 7, we're on dividing complex numbers now. So we've just looked at how to multiply complex numbers. Now we're going to look at how to divide complex numbers. So I'm just going to remind you, or show you rather, about what happens if we were dividing by something like that, 5 plus root 2. So you would hopefully remember that we would times top and bottom by the conjugate of the bottom. Okay, well, the same thing's going to happen with complex numbers. We're going to times top and bottom by the conjugate of the bottom. So, first of all, let's just have a new word. So instead of conjugate, I'm going to use the word complex conjugate. So if 5 plus 3i is my complex number, then we say 5 minus 3i is my complex conjugate. I just changed the sign of the imaginary part. So if this here is my z, then the notation we use is z and a little star. So z star is that. So if z was equal to 7 minus 5i, my complex conjugate would be 7 plus 5i. If my complex number was 10i plus 15, what do you think my complex conjugate would be for that one? Minus 10i plus 15. It's always the imaginary part that we change. Okay. So let's see why that's useful. Because we know why that was useful with complex with surds, because 5 plus root 3, when we times it by 5 minus root 3, we got 25 plus 5 root 3 minus 5 root 3 minus 3. And these two bits cancel out. Well, let's look what happens when I have 5 plus 3i and 5 minus 3i. So a complex number times its complex conjugate. 5 times 5 is 25. 5 times minus 3i is minus 15i. 3i times 5 is plus 15i. And 3i times minus 3i is minus 9i squared. Well, these bits cancel out. And I squared is minus 1. So minus 9 times minus 1 is plus 9. So 25 plus 9, which gives us 34. So I started with two complex numbers times together, and I get a real answer. And that'll work with any complex number. So if I do algebra now, so a plus bi and a minus bi. A times a is a squared. A times minus bi is minus abi. Bi times a is plus abi. And bi times minus bi is minus b squared, I squared. They cancel out. A squared, I squared is minus 1. So minus b squared times minus 1 is plus b squared, which again is a real number now. Okay, so we can now use this now to start dividing some complex numbers. Also, there's something interesting when you add a complex number and its conjugate. I'll leave that for you to explore in the questions further below. So let's do 5 plus 4i divided by 2 minus 3i. Okay, well, the first thing to do is both of them are complex numbers, but if I divide by a whole number or any real number, I can do that easily. So it's the bottom bit that I need to get rid of. I don't like having complex numbers in the bottom of fractions, just like we don't have we don't like having surds on bottom of fractions. So I'm going to times by the conjugate of the bottom. So 2 plus 3i on the top, 2 plus 3i. Okay, then it's just a case of expanding the brackets. So on the top, 5 times 2 is 10. 5 times 3i is 15i. 4i times 2 is 8i. And 4i times 3 is 12i squared. And on the bottom, 2 times 2 is 4. 2 times 3i is 6i minus 3i times 2 is minus 6i, minus 3i plus 3i is minus 9i squared. Okay, simplify the top and the bottom. So I've got 10 plus 23i. Remember, I squared is minus 1, so I get minus 12 divided by 4. They cancel out. Minus 9i squared, so that gives me plus 9. So minus 9 times minus 1. So that gives me minus 2 plus 23i. 10 to equal 12 is minus 2 divided by 13. So that's my answer. It's a complex number. If you want to write it as real and imaginary parts, it would be minus 2 over 13 plus 23 over 13. Yeah, just like thirds. So I'm not going to do another example here. Key thing is times by the complex conjugate of the bottom, the denominator. Yeah, do the same to the top, bottom, expand, and it's simplified, work through it all the way to the end. Yeah, you might be able to speed up the step times in the bottom because you can just spot a pattern to get from here to here quickly, hopefully. Anyway, have a go at the questions and see what you manage to come up with.